everyone. Welcome to another Open Cluster Management community meetings. Today we have two topics. First one, Min Kim's gonna guide us on how to onboard some Helm charts to our OCM community. And then afterwards, we have Long Cow, who's gonna talk about a repo that he's suggesting, a multi-cluster mesh add-on. So without further ado, Min Kim, if you'd like to begin first by sharing your screen and do your presentation. Thank you very much.
Yep. Thank you, Mike. I'm gonna share my screen. Can you guys see my screen now?
Yes.
Okay. So we had a new repo in the Open Cluster Management organization, and as you can see, this is a binary repo, which is saving all the Helm charts manifest in table under this directory. And so this is how basically how this repo works. From the perspective of the consumer of this Helm chart repo, we're gonna add this repo into our local Helm charts repo. And simply by running this command and run Helm repo updates and search repo OCM, then we're gonna download all the existing Helm charts from this repo. I will show you on my terminal. Can you see my terminal now?
I can't see it. Can you guys see it? Oh, yep. We can see it now.
Okay. So I'm gonna run this command on chart repo add OCM. But I already had OCM, so how about the OCM2? Yes. And then I run repo update. Yep. Then Helm search repo OCM2. And it's gonna show all the existing repos. As you can see, there are a few add-ons of OCM and
sorry, Min Kim. I think there's a bit of lag, or it's not showing the latest update on your terminal. Oh, I can see it now. I think it just lags. Okay, sorry. Go ahead.
Okay, thank you for reminding. I just opened my my proxy toolings. Please let me know if I'm laggy again. So as you can see, there are a few OCM add-ons already present in this repo, and another a dummy Helm charts, which is for testing the info of this repo. Which is I'm gonna demo in a follow-up to show you how the automated workflow works. Okay, let's get back to the Helm chart repo. This is how to use the Helm chart repo from the perspective of a user. And how about repo admins? So for now, there are two ways to upload Helm charts into this repo. One is where.
Sorry, Min Kim. We only see. Sorry to interrupt. We only see a blue screen.
Oh. I think I need to. I need to switch my screen sharing manually.
Yep, we can see it now.
Okay. So in the README of this repo, there's a section named upload, in which I I wrote that there are basically two ways to upload Helm charts in this repo into this Helm charts repo. One is to upload manually via pull request. So intuitively you can just clone this repo and git add then just open a new pull request to this repo, then which will triggers a post commit workflow, which is uploading all the Helm charts under the charts directory onto a blob storage, which is the billing of the blob storage is provided by these guys from Microsoft. So I really appreciate their help. And the another also if you have the collaborator access to this repo, you can also like manually download some Helm charts from third-party repos by running this workflow, but this is only visible from collaborator view. But this manual workflow can also be triggered from other repos by which is the second approach I'm gonna show you, is uploads via GitHub action. So you can add this GitHub action steps into your own repos, and as you can see, the content of this step is just invoking the workflow from another repo towards this Helm chart repo and triggering that job I just showed you. So there are three parameters, which the one is the GitHub repo. The second one is the target's GitHub version, and the third is the Helm chart's name. If you provided all three of these parameters, then the job is gonna browse into the for example, I will take the dummy repo as an example. Charts, it's a Helm charts dummy. I think it's dummy is here. So as you can see, we can if we fill all these parameters, then the workflow from the Helm charts repo will browse into the release page of each separate repos and download the corresponding Helm charts releases from the attached release assets. For example, if we fill my GitHub handle and Helm charts dummy and fill the version of 1.0.1 and the Helm chart name is dummy, then this particular Helm chart table will be downloaded to the chart directory, and which will also trigger the post commit GitHub workflow to synchronize all the contents under this directory to the remote blob storage. So here's another picture showing you how the workflow works. I will zoom in to have a better view. Okay. So if I'm a repo admin, then I can just push tag a new tag and push it to the remote upstream repo, which triggers the release workflow, which is the currently most of the workflow, the release workflow we are exercising. For example, we are doing that in registration work, and if we are adding this GitHub action steps to the end of the release workflow, then at the end of the release, they will notify the Helm chart repo to download the Helm chart tables from each repos, and at the end, the Helm charts repo will push the Helm chart tables to the remote blobs. And so it's recommended to work in automatic pattern between all the existing repos from OCM organizations. But we can also download. We can also work in the download or manual pooling pattern if the repo publishing the add-on is a third-party add-on. By third-party, I mean the repo is not under OCM organization. And here's also a text steps description telling you how the workflow works. You can read it together with the picture. And next, I'm gonna have a brief demo of how to publish Helm charts from my terminal using that dummy Helm chart repository. So in this this part is my GitHub workflow of the Helm chart dummy repo, and I will briefly show you the contents of it. First of all, the release flow will just check out the code and prepare some environment variables. Then it's do the Helm chart packaging using the Helm chart commands by Helm chart package, and they just publish a GitHub release. Then at the very end, it's the trigger step, which triggers the downloading to our central GitHub repo. Then we can just first of all start by currently the latest release is okay, it's 1.101. Make it 1.102. Sorry. I think I need to update the Helm chart metadata. Otherwise, in the release workflow, there's a validation step. There should be a validation step, or such that the Helm charts release, the Helm charts tags are matching the release tags on the Git commit. Yeah, for some cluster, for some repo admins, like we can make mistakes when we are manually managing the tags. For example, we can forget to bounce the versions in the Helm charts, which so just don't forget that. Then we can yes. Then I will publish a new commit. And I'm signing my commits using my GPT key, and I'm pushing it to remotes. It's oh, no, I can just push my text. Oh. And oh, did I just forgot tagging? Oh, alright, now it works. Let's switch back to the web page. We are supposed to see a release workflow running in the background. So as you can see, this dummy repo is doing the release. And here we had a 1.102 release in the release artifacts page. At the end, it should triggers this central Helm chart repo to download from the dummy repo. And yes, as you can see, 50 seconds ago, there's just a new Helm charts with version 1.0.2 like automatically submitted to this directory, and the corresponding blob storage has also been refreshed. We can run Helm repo. Yes, it's a Helm repo update. Okay, then search repo CM2. So you wait a sec. Is it still? No, it's still running. Yep, it's still running. It's uploading to blob storage. Sorry guys, it's still running a few seconds ago, but now it's successfully uploaded. So let's get back to terminal again. Then we run Helm search repo. No, it's Helm repo updates. Know that the uploads, the publish workflow in the central Helm chart repo is running a bit slower because I intentionally had a step which is but you can see there's a new tag, there's a new chart with version 1.0.2. I just made the release section a bit slower intentionally because I knew the step which is this one. This step will help us to serialize, make sure all the publish workflow running in a sequence. Otherwise, if there are multiple publish workflows running in parallel, then there might be some. Then the remote blob storage will contain some stale data, because every time we do the publishing, we are synchronizing all the Helm charts tables from this directory to the remotes. So it has to be running in sequence. Okay, and here's how this central the Helm chart repo in OCM works now. And there are still a few leftover issues in this repo. For example, as you can see, all the commits which is automatically pushed to this repo are signed by me. This is because the GitHub the GitHub workflow is by default the GitHub workflow doesn't allow cross-repo interactions. So every workflow in a GitHub repo is authenticated using a GitHub token. But if we want to allow cross-repo authentication, then we will need PAT token, which is personal authentication token. So temporarily, I'm using my PAT tokens to configure the dummy repos. So when I use my personal PAT token to trigger the workflow to trigger the workflow of this central repo, then the author of the automated commits will be just me. I think we can replace my personal PAT tokens to a, for example, OpenShift CI robots account. Anyway, it just needs to be a robot account, I think. In the Kubernetes, they had a Kubernetes publish bot, CI bot, etc. And the second thing I need to clarify is that some of you may wonder why the workflow is working like this, why we are firstly downloading some charts from other repos, then run the release flow instead of just for example we can just let the per repo admins to trigger a workflow to directly open a merge request against the central repo. I tried that initially, but it didn't work because I didn't find any open source GitHub actions supporting cross-repo merge request. I'm not sure if it is a limitation due to the GitHub workflow infra. But they're working equally, I think. I think that's all about it. Do you guys get any question?
Yeah, I just have a basic question about the authentication, because in your workflow chart, the user editing or updating the chart is on the other repo and not on the Helm charts repo. So how does it have permission to create the PR or trigger the workflow? Is it just because we're all under the same organization, those same organizations?
Yes, that's a really good question, Mike. Actually, like on the GitHub browser, opening a merge request doesn't require any permissions. You can just for example browse into this repo and for example you can just fork it, then open a merge request via I think you can just open the merge request by clicking these buttons. And as for automated workflow, yes, we will need to configure a PAT token to each of the repos. That's why, as I said, the automated, the reactive workflow only works in the repos under OCM organizations, because we need to set the PAT tokens to allow the per repo admin to trigger the download workflow of central Helm chart repo. And the PAT token has many different levels of permissions. So I think the permission of the token can also be scoped, limited to just triggering the download workflow. Am I addressing your question?
Yeah, thank you.
Yep. Ideally, I think we can get the PAT token from the OpenShift CI token. Oh, sorry, it's OpenShift CI robot. Then every commit will just looks more like it's automated commits. For now, it looks like all done by me, but actually it is not. It's just triggered. It just shows the signer, the owner of the PAT token. And as a follow-up, I think we can also publish a GitHub release in the package page. In the release page of the central Helm chart repo. So every time there's a new Helm charts added to this central repo, not only our OCM add-ons or OCM Helm charts or other third-party add-ons, they will just show the new contents in the release page. Yep, that's all from me.
Thank you, Min. Are there any other questions for Min regarding the Helm chart? Okay, Long, your turn's up. Please share your screen.
Yeah, let me share my screen. I think you should see my screen.
Yes, we can.
Okay, so today I want to propose the multi-cluster service mesh add-on on the open cluster management. Before I start the demo, I want to introduce some background knowledge about this add-on and some use case and core concepts. The background. So currently for the multi-cluster service mesh and the community issue suppose the multi-cluster capability out of the box, but the capability is limited. If you try to set up a multi-cluster service mesh with ECU, you can see that there are many manual steps, and the steps are very easy to record errors. So also there are some third-party service mesh provider also suppose the multi-cluster or multi-mesh functions. For example, the group mesh, also the OpenShift service mesh, and maybe the other, for example, the Untitled service mesh and the GKE service mesh. But consider that in the open cluster management scenario, what we already have in open cluster management, we have the cluster lifecycle management, and we also have the add-on framework and a lot of other add-on. For example, the application add-on to application subscription add-on to deploy your service or application to many clusters. And we may also, I heard that Sabrina is also want to contribute to the OCM, right? So Sabrina is also very good networking tunnel for the clusters. So consider that we have all these concepts in OCM. I think we can build an add-on, and we can just create some more high-level concept on the upstream issue, and then we use this concept or API to let the user to set up service mesh or set up multi-cluster service mesh. So that's a basic knowledge of the background. Let's talk about the use cases. Currently, we want to focus on the mesh level. It means that it's just focused on the, you can see that it's focused on the control plane of the service mesh. The first use case is about mesh discovery. For example, if you have a cluster have already developed issue service mesh, and then you join this this cluster to the OCM hub cluster, then it should be the mesh add-on should discover this already existing service mesh. So this is a mesh discovery. And the mesh deploy or mesh configuration is just straightforward. So it means that we can just from the OCM hub cluster to deploy service mesh, and maybe also we can update or configure more details about this mesh. The third is about the mesh federation. It means that if we have two mesh in too many clusters, and we want to federate to mesh, we want to make the service in different many clusters to access each other. How can we do that? This is a bad mesh federation. And based on the use cases, we create some core concepts for each use case. The first use case is the first concept is about mesh. A mesh resource is mapped into a physical service mesh in the many clusters. So if there are already some service mesh in many clusters, or you deploy new service mesh in many clusters, it should be in the hub. It should be create a mesh concept, mesh CR or mesh resource in the hub cluster, and this mesh resource should contain some important abstract information about the physical service mesh. For example, currently we have this information in mesh. For example, the control plane components, you have enabled what's component. For example, you have enabled the ECO daemon or the ECO ingress gateway, and maybe other, for example, the promises or other components. And we also have the control plane namespace and the profile. The profile is actually the ECO concept to simplify the ECO's installation. Here we just get the profiles and show it in the mesh. And also we have the physical ECO mesh version. And we also have some other fields. For example, the mesh member rule. It means that what namespace is this service mesh is managing. It means that which namespace your ECO application is deployed, and also the mesh provider. So for now, we suppose the upstream ECO, and also the mesh configure. You can see that the trust domain is very important for the mesh federation. I will introduce it later. And besides the mesh, we also have mesh deployment. It's used to deploy physical service mesh to many clusters. Actually, the mesh deployment have very similar contents with the mesh, but as you can see, we make slight change to the mesh. For example, we suppose the clusters. It means that we may want to deploy service mesh to multiple many clusters with one mesh deployment resource. So you can just specify your target clusters in the clusters field, and other field, as you can see, is just similar to the mesh resource. It's very straightforward. So I will skip to the mesh federation. Mesh federation used to federate to service mesh spanning different many clusters. And we also want to make sure that each mesh maintains a strong administrative boundary. It means that maybe that each mesh is have its own say serve, or just in have different mesh administrator. So we want to build the trust between the mesh, but we don't want to just share the same administrator boundary. So here, as you can see, the for the mesh federation response, we can define which mesh peers want to be federated. For example, in this example, I want to federate the cluster 1 mesh and cluster 2 mesh to federate. And we can also specify the trust type. Currently, the trust type is supposed to complete. It means that the C actually each mesh has the intermediate C, but they are aside from the same root C. This is complete trust. But I think we can later suppose some limited trust. For example, since our traffic between the clusters is actually routed through the ECU gateways, so we can just build trust at the gateway. So we later we will suppose the limited trust just gated at the ECU gateways. So this is a three core concepts for the mesh add-on. And this page is about more details about this mesh, especially for the mesh federation part. For the mesh federation part, I want to clarify that we want to route traffic between the clusters with the ECU gateways, but consider that Sabrina maybe also contribute to the OCM. I think in the future we may want to support another traffic. We can just route the traffic with the Sabrina tunnel between the clusters. I mean this part, and also I just introduced that we currently we suppose a complete trust. Just by signing, you can see that this is the intermediate C, and actually they are just aside from the same root C. This means that we just we currently use a complete trust, but in the future we will support the limited trust gated the gateway. So let's see a quick demo for this. As you can see, I have created four kite clusters. The first is the hub cluster, and the three kite cluster will be used as a managed cluster, and I export the environment variable that will be used in this demo, and I install the cluster manager in the first kite cluster, and it will be the hub cluster of the OCM, and I also joined the three other many clusters to this hub, and you can see that join is successful. I want to clarify that there are no special settings for this kite cluster. You can just follow the quick started of the OCM document to set up these clusters. And then we can just deploy the multi-cluster mesh add-on. I close the repo and switch to the kite hub and then deploy this service mesh add-on. Yeah, after its deployment, I just make sure that the service mesh add-on is running in hub cluster, and also the multi-cluster mesh agent is running the main cluster. So this is a add-on in the hub cluster. And this is an agent role in the managed cluster. It's up and running. Actually, you can also just check the managed cluster addon CR to make sure that it's created for each managed cluster. And then we deployed an issue service mesh in the cluster managed cluster 3. We want to show the mesh discovery functions. As you can see, we just directly deploy this service mesh in managed cluster 3, and then it should be create a mesh resource in the hub. Yeah, as you can see, we justified that a mesh resource is created in the hub cluster, and it's contains the basic information about the mesh. For example, the version, the provider. If you check the mesh YAML, you can see more details about this mesh. For example, the components you have installed, and the profile, and the reversion, and the trust domain. So let's go on. So this is a mesh discovery. So I want to, the second scenario is about the mesh deploy. I want to create a mesh deployment resource in the hub cluster. The mesh resource, I want to deploy the service mesh in managed cluster 1 and managed cluster 2. And I want to deploy these components of the Istio control plane and in the Istio system namespace and the version, and also the Istio application namespace is bookinfer. I want to later show the bookinfer to make sure the mesh is deployed successfully. And we just create this mesh deployment resource in hub cluster, and then we can verify the mesh is actually created in the managed cluster. We can see more details. This is a managed cluster 1. It may take a few seconds for the mesh actually created. Yeah. Actually, it is, yeah, the gateway is also up and running. So let's check another mesh. This is a mesh in managed cluster 2. As you can see, it's also up and running. So this is about the mesh deploy. I want to make sure the mesh deploy is successful after I just federate the two service mesh created just in last step. So I will first show the mesh federation and then verify the whole mesh is working by deploy bookinfer application. So for the mesh federation, I just need to create a mesh federation resource in the hub cluster, and I want to federate the two meshes, and I want to use the complete trust to create the mesh federation in hub cluster. And finally, actually till now the three use cases covered, but I want to make sure the mesh deploy at the mesh federation is working. So I want to deploy the bookinfer application in different clusters. So I deployed part of bookinfer application in managed cluster 1 and another part of bookinfer application in managed cluster 2. And you can see I deploy the product page details review V1 and V2 in managed cluster 1. And I will deploy the review V3 and ratings in managed cluster 2. And this is review v3. And this is review service. Service account. And finally, the rating service. So let's verify that the booking ver is actually. So we verify the booking ver is start up and running in Multicluster. As you can see, in Multicluster 1, we have this service of booking ver, and in Multicluster 2, we have another part, review v3 and ratings service. So till now, booking ver is up and running. So I want to make sure that the service in Multicluster 1 can access the service in Multicluster 2. I want to deploy a service entry in Multicluster 2 to export the review v3. Here I quote the export because it's actually just we may do some future work to make the export service more convenient. So first, I want to create this use the review v3 port IP to create the service entry in Multicluster 2, and then we export this review v3 service in Multicluster 1. And here, in the service entry, it's just this issue concept. The address should be the second the issues east-west gateway IP, and the port is issue gateway node port. In Cat cluster, I just use the host Docker IP and the node port. But if you run it in the, for example, in the ECAS, it should be support the load balancer IP so that you can just access the remote service through the load balancer IP of east-west gateway. So here our deploy has successful. I just want to port forward the booking for service, and then let's access the booking from our browser. As you can see that actually this red star represents the review v3 version, and it's actually deployed in Multicluster 2, and other parts, details, and how the product page is actually deployed in Multicluster 1. So you can see the red star in the product page. It means that the product page can access the review v3 in Multicluster 2. It means that the mesh validation and mesh deployment is successfully. So I think that's all for my demo. As you can see that for the verification, we have many manual work to deploy the booking verification, to deploy the service entry and other resources. So this also brings us to the future work of this mesh add-on. So currently, I have mentioned that we focus on the mesh level. So in the future, I think we need to focus on maybe the service and the workload discovery. We want to just automatically maybe create this service entry, and we want to use the application subscription or other method to deploy booking for or other application across many clusters. And we may also want to federate the service. I mean, for example, the review v3, it can be we just don't want the user to create this lot of issue resources in the many cluster. We just want to create some concepts in the hub cluster. They just create the resource in hub cluster, and the whole service can be accessed cross-cluster. I think that's all for my demo. So do you have any comments or questions?
Yeah, I think this is a very interesting idea. I saw the issues about creating a repo on the OCM to hold this add-on. I actually, I'm not sure whether there's other comments on this issue. I think it should be fine. The only thing that when I take a look at the API is, maybe you could consider about that using the cluster set and cluster set banding concept in define the boundary of the API. Like when a mesh deployment or mesh federation is created, it must be in a namespace of a cluster set banding, and it should be the clusters must be in the cluster set or in other some way, but the cluster set banding should be able to provide a boundary for the mesh deployment and mesh federation.
Yeah, it's a good strategy. So we are still thinking how, yeah, currently we just use the most easy way to deploy the mesh. So I think we can integrate more the OCM concepts to this API.
Yeah, and also I think that's also if we have a repo about this add-on, I would assume that we also have a Helm chart that could be uploaded into the Helm chart repo for the user to test.
You mean the Helm chart for the addon itself?
Yes.
Yeah,
Yes.
okay. Yeah, I can do that. So any other comments or questions?
Thank you, Long Long. That was an amazing presentation. I'm looking forward to try it out after you onboard the demo and then provide the steps on the website and the Helm charts as well.
Yeah.
If there are not any more questions, I think we're gonna wrap it up for today. Thank you everyone for coming in. Take care. Bye.